Okay, so today we're going to be looking at the quadratic formula. The quadratic formula is really helpful if something isn't factorizing very easily. We can either use completing the square or this guy right here. So if ax squared plus bx plus c equals 0, and that's really important, it has to equal 0. If this doesn't equal 0, then you're going to want to move everything to the other side. So if this was 5, you'd want to take away 5 from both sides. It only works when it equals 0. Because we've shown in another video that if we were given this guy, ax squared plus bx plus c, the solutions to this in terms of a, b, and c are negative b plus or minus the square root of b squared minus 4ac over 2a. So using the quadratic formula, it looks scary, but it really is just a case of substituting these values in. If this was a 2, x squared, where we have a, we write 2. If this was 5, we'd write 5 for the b's, and if this was 6, we'd write 6 there. It really is just a case of substituting the values in. So it looks like this big thing that no one can remember what it is, but it's really helpful. Okay, so for our first example, we're going to do x squared minus 7x plus 10 equals 0. So a pretty standard first example. So what we're going to do is we're going to write down what a, b, and c are. So in this case, a, the coefficient of x squared is 1, so a is 1. The coefficient of x is minus 7, so b is minus 7. And then the constant term is 10, so c is 10. So now that we have these down, it really is just a case of putting everything in this little machine we've got up here, the quadratic formula. So x equals negative 7 is, sorry, let me move that across. Negative 7 is just 7, plus or minus the square root of negative 7 squared. So I'm going to leave it in the brackets here just so it's clear what we're doing. Negative 7 squared minus 4ac. So minus 4, a is 1, so we can just kind of ignore it, but I'll put it there just to be clear. And then c is 10, so we'll put another 10 there. So all of that square rooted, all over 2a. So a is just 1, so 2 times 1 is just 2, all over 2. Okay, so we'll simplify this a little bit more. So that is actually the right answer, but we're going to want to simplify it so it's easier to read. So 7 plus or minus, so we've got 49 is minus 7 squared, minus 4 times 1 times 10. Well, that's 40. So 49 minus 40 is 9. So that's worked out quite nicely. It's plus or minus the square root of 9 all over 2. So we're going to keep simplifying that. So we're going to split up the plus or minus now. So we're going to have 7, well, root 9 is 3. So we've got 7 plus 3 over 2, or 7 minus 3 over 2. And really, that is just, well, 7 plus 3 is 10 over 2 is 5. And on this side, 7 minus 3 over 2 is going to be 4 over 2, so it's just 2. So these are the two solutions. And I was hoping it would be that because I specifically chose them. Because if you've noticed, we can just factorize this. We didn't actually need to use the formula. So with the solutions that we've got, we know that we can just write x minus 5, x minus 2. And that would give us x equals 5 or 2. So we can use either method. You can just see that we save a lot of time factorizing, but if you really are stuck, then just use the quadratic formula. That's why it's so useful, because it's going to give you the right answer every time as well. Okay, our next example is 2x squared minus 4 equals minus 3x plus 6. So as you know, we're going to want to take everything to one side. So we're going to take everything to the left. We could take it to the right and have negative 2x squared plus 4. But I like to have my edge positive. So we're going to add 3x to both sides. So we've got 2x squared plus 3x, and then take away 6 from both sides. So minus 4 minus 6 is minus 10, and all of that equals 0. So we see that our a term is going to be 2 because it's the coefficient of x squared. Our b term is going to be 3, the coefficient of x, and our constant term c is going to be negative 10. Negative 10. Okay, now that we've got that, we can just substitute everything in. So we've got x equals negative b, so negative 3, plus or minus the square root of b squared, so 3 squared, minus 4 times a, which is 2, times c, which is minus 10, square root of all of that, all over 2a, so 2 times 2. And then simplifying that, we're going to have minus 3 plus or minus the square root of, so we've got 3 squared is 9, we've got a negative here, so all of this is going to be plus, and 4 times 2 times 10 is 80. So 9 plus 80 is 89, all over 2 times 2 is 4. And finally, splitting up the plus minus, we're going to have minus 3 plus root 89 over 4, or minus 3 minus root 89 over 4, minus root 89 over 4. So this has been really helpful because we would not have been able to find this answer by factorizing. It would, or at least it would have taken us a very long time to do so. Okay, our next example is x squared minus 2 root 3x plus 3 equals 0. So this time it's a little bit different because our coefficient of b is 2 root 3, which is allowed. Normally we're used to nice whole numbers for our coefficients, but again, b can be any number, so we've chosen minus 2 root 3. So, but we're going to do the same thing as before. We're going to have a is 1, sorry, you can see that a is 1, b is minus 2 root 3, and c is 3. We've ran out of room there again. We're going to have a running out of room counter. So now that we've got our guys there, we can just substitute everything in again. So x equals negative b, so negative 2 root 3 is 2 root 3, plus or minus root b squared, so we can ignore the minus because we're squaring it. So 2 times 2 is 4, root 3 times root 3 is 3, so 4 times 3 is 12. Minus 4ac, so 4 times 1 times c is 4 times 1 times 3. I'll write it all down just so you can see. All over 2a. So 2 times 1 is 2 again. Sorry, I feel like a is always 2 in this video. a can be anything, but this is a coincidence, all right? So simplifying that, we've got 2 root 3 plus or minus 12 minus 4 times 1 times 3 is 12. So we've got 12 minus 12 is 0. So we've got plus or minus 0, kind of crazy, all over 2. So the reason I chose this example is because it's an example of a repeating root. So if we simplify this, plus or minus 0 is 0 both times. It's not doing anything. So we can just cross it out. I wouldn't, in your exam, don't do this. Write another line, but I'm just showing you that we just ignored that. Don't just cross it out if you need to show your full working, because it's a little bit hard to follow. But this really is just a case of 2 root 3 over 2, which is root 3. So x is root 3. And so if we were to sketch a graph of this, let me do it here. Root 3 is our only solution. So root 3 is a little bit less than 2, so it would be about here. Not that this graph is to scale anyway, but it would be here. So the graph would do this. It would come down and it would just touch it there and then come back up. It wouldn't go below 0. And so it's really useful to know about this, to know like what it is in context. This is what the graph is doing. So this graph is always positive, apart from when x is root 3. And so this is just really important because often in your exam, you probably won't just get questions. It's not just a case of solve it and find the solutions. It might ask you to show that this function is always positive. And the way that you can do this is, well, you find when it is 0. And luckily, we only have one solution. So we know that it's only going to touch 0 once. So it's not going to dip below the x-axis. Okay, so for our final example, we have 3x squared plus 2x equals minus 5. So you know what to do here. We're going to rearrange. So we're going to add 5 to both sides. We're going to get 3x squared plus 2x plus 5 equals 0. And then we're going to write down our values of a, b, and c. So a is going to be 3, b equals 2, c equals 5. So coefficient of x squared is 3. That's where 3's come from. Coefficient of x is 2. Coefficient of, well, the constant term is 5. So we've got all that we need now. We're going to substitute everything into the formula at the top there. Sorry, I hope you can see that. It's not very easy to memorize that. So x equals negative b, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, so 3 times c is 5, so all of that square rooted, all over 2 times a, so 2 times 3. So simplifying that, even though it is the right answer, negative 2 plus or minus 4 minus, so 4 times 3 times 5 is going to be 60. So 4 minus 60, oh no, we're going to have a negative, but we'll come to that in a sec. 2 times 3 is 6. So splitting this up, we're going to get minus 2 plus, so 4 minus 60 is minus 56, I think. Yeah. So we've got root minus 56. So we're gonna have imaginary numbers, imaginary solutions, I should say. So if you don't know what those are, then you can kind of stop here and just say it has no real roots, and we'll look at the determinant another time, but that's because the determinant is less than 0. But if you know what imaginary numbers are, we'll keep going. So it's minus 2 plus root negative 56 over 6, or it's the other, it's negative root minus 56 over 6. Sorry, that's not very neat. Okay, so simplifying this a little bit more, we're going to have minus 2 root minus 56. We're going to have an I on it. So say we had root 56. Instead, we'd have root 4 times root 14. And root 4 is 2. So we've got plus 2 root 14i. And if you want to check that that's right, we can put everything back in their root. So I is root minus 1. 2 is root 4. So we'd have minus 4 times 14 is 56. So we got that right. All over 6. And then the same on the other side, but with a negative instead. So minus 2 minus 2 root 14i over 6. And then finally we can take out, we can simplify that a bit more. We can divide top and bottom by 2. So we get minus 1 plus root 14i, or minus 1 minus root 14i over 3. Sorry, over 3 for both of them. Yeah, we're really running out of room here. So if you know what imaginary numbers are, those are the solutions. That's what x equals for both of them. But if you don't, if you haven't studied them, then you can just write up here. We can see that we've got a negative in the square root here. So we can just say that there's no real solutions in that. That's quite important that we say there's no real solutions, because there are solutions, they're just imaginary.